Singing N1 sine theta sub 1, hey, 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 equals N2 sine theta sub 2, hip hooray.
The law of refraction is also known as Snell's law, named after Willebrord Snell. It describes the relationship between the angle of incidence and the angle of refraction when referring to light passing through a boundary between two different isotropic media. Here we see a diagram of light passing from one media to another. The refractive indices are labeled as N1 and N2. The angle of incidence is theta sub 1 and the angle of refraction is theta sub 2. Note that the dashed line is perpendicular to the surface and that the angles are measured from that perpendicular line. Let's go through a quick example. N1 is the air in this case, and the light is passing into a media with refractive index 1.5. The angle in this example is 45 degrees. As you work out the equation, you will find that when the light passes from a lower refractive index to a higher refractive index, the emerging ray is bent towards the normal. Let's work out the numbers. This law can be used as light passes through multiple layers. Again, you may notice in this diagram how light passing from a lower refractive index to a higher index will bend the light towards the normal. When it passes from a higher refractive index to a lower index, the light bends away from normal. If there are multiple refractive indice interfaces, and the refractive index for the incident media is the same as the final emergent media, the first angle of incidence equals the final angle of refraction, so theta sub 1 would equal theta sub 4 in this example.
Singing N1 sine theta sub 1, hey, 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 equals N2 sine theta sub 2, hip hooray.